you can see here, in matrix multiplication, we usually multiply a row of a matrix with a column of another matrix and then take the summation of the products. Likewise, we repeat this process for all rows and columns. In the matrix multiplication process, we start by taking two matrices A and B, and first ensure that the number of columns in A is equal to the number of rows in B. If not, display error. If yes, we initialize a result matrix C with appropriate dimensions. Then for each row in matrix A, we multiply its elements with the corresponding elements in each column of matrix B, summing up the products to get each element of the result matrix. This process is repeated for all rows of A and all columns of B. Finally, the completed result matrix C is displayed as the output. For easy understanding, I have broken down the code step by step. Let's dive into it. In this code, we are checking whether matrix multiplication is possible by comparing the number of columns in matrix A with the number of rows in matrix B. If they are not equal, the function prints an error message. In this case, since matrix A has 2 columns and matrix B has 3 rows, they do not match. So, the function correctly prints the error message. It says matrices cannot be multiplied. Step, we are initializing the result matrix with zeros. This can be done in two ways. The first way is by creating an empty list C, then using nested loops to build each row by appending zeros and finally appending each row to the result matrix. The second, more concise way is by using list comprehension, which creates a matrix filled with zeros in a single line. performing matrix multiplication using three nested loops. We take each row of A and each column of B, multiply the corresponding elements, and sum them up to get the result for each cell in the result matrix C. We are also printing each multiplication step to trace the computation. Here we are calling a function multiply matrices function with matrices A and B. If the result is not none, we print each row of the resulting matrix to display the final output.